In this video, we're going to discuss some of the basic factoring methods you need for Algebra 2. We're not going to discuss all of the factoring methods. These are really the factoring methods that you should already know from Algebra 1 and previous grades, but you didn't use them a lot in geometry last year, so maybe you need a little reminder, and so that's really what this video is for. So first, the basics, and the basics are GCF, which stands for greatest common factor, and that's what our first example is, and then I'll go through the others. So GCF, greatest common factor. And that's always the first factoring method you want to look at when you're deciding how to factor a problem. You want to look at the terms you have and say, do they have anything in common? And both of these terms have an x in common. So we could factor out an x. And factoring out is really a form of division. Right? I'm dividing out an x. Sometimes we say take out an x, but really we're saying divide out the x and put it outside. So when I divide x squared by x, I have a remainder of x. And when I divide negative 4x by x, I get negative 4. Factoring really is division. If you think about it, I'm, creating two terms that multiply to my original. Like when you factor the number 20 to 4 times 5, well, 4 times 5 multiply to 20. I came up with two numbers that multiply to 20. They're factors of 20, 4 and 5. Same thing with x and x minus 4. Together, if I multiply this back, I go back to where I started. So you are kind of doing a division, but not dividing a polynomial by a polynomial. You're kind of dividing a polynomial within itself. All right, this next term. So let's see. Is there a GCF between these three things? No, they don't all have an x in common. I can't divide them all by the same number except for one, but of course that won't do anything. And there's three terms here. That's why we call this a trinomial. And there's some basic trinomial factoring, and then there's some advanced trinomial factoring. The basic trinomial factoring is when your lead coefficient, your a term, we refer to it, the coefficient of x squared is the invisible 1. And we could write a 1 there if we want. Now, if there's a number here like 3 or 2 or something like that, then it's a little bit more advanced. Of course, I want to see if it happens to be a GCF, but often it's not. And we'll see that come up at some point. But for now, the basics, where there's no number in front of x squared besides the invisible 1. Trinomials factor to two binomials. So we always like to set it up as a double parenthesis. And there's going to be a binomial here, much like x minus 4, and a binomial here. The front terms of the binomials multiply to x squared, so that would be x and x. And then the numbers that they are paired with, they have a characteristic of multiplying to negative 10 and adding to positive 3. It's helpful sometimes to write AM on top. Now, as I shoot this video, it's 12:34 p.m., but, just like the time, AM, PM. It's helpful to write that because a common mistake students make is they reverse that. They think multiply to 3 and add to negative 10, and that'll mess you up. So what multiplies to negative 10 and adds to 3? The answer is positive 5 and negative 2. You have to be pretty good at working with, just sign numbers, adding, subtracting, and multiplying. If that's not a strong suit of yours, there's calculator tricks and things like that, but factoring's kind of tough if you're not great with operations with numbers. If you're really good at adding, multiplying, subtracting, dividing numbers, positive, negative, then factoring should be pretty easy as long as you remember the procedures. But you do have to be careful with that. A common mistake there is thinking that it should be negative 5 and positive 2. Well, the problem with that is they would add to negative 3, not positive 3. Or sometimes people just think 5 and 2. But they would multiply to positive 10, not negative 10. The fact that they multiply to negative tells me they have to be different signs. And, so you just have to be careful with it. You should be far enough in school at this point that you've worked with this a lot, but it's still very common to make human errors, little mistakes. So you just need to watch out for it. Our third example on this page is 4x squared minus 9. Again, I want to start by looking for GCF. Is there a GCF? No, there's not. And it's not three terms, so it's not a trinomial. This is what we call a difference of two squares. And we abbreviate that as dots. Difference of two squares. The first word is difference. That's why there's a subtraction in between. Difference means subtraction. A subtraction of two squares. It's another word for difference. And so if this were a plus sign, then it's not a difference of two squares, and it actually can't be factored because there's no GCF. Now, not only that, it's difference of two squares. So it has to be a binomial. There's two terms here. It's a binomial. And they're squares. What does that mean? Well, square numbers like 1, 4, 9, 16, 25, 36, those are square numbers. And x is squared. It doesn't have to be x squared. Even if it were x to the 10th, that would still be considered square. A variable with an even exponent is considered square. And then square numbers you should be familiar with at this point. 1, 4, 9, 16, 25, and so on. So the numbers have to be that. So if this was 4x squared minus 7, not a difference of two squares. But 4 and 9 are squares, x is squared. A dots, or a difference of two squares, also factors to two binomials like a trinomial does. And the front pieces, just like x times x was x squared, well, they need to multiply to 4x squared. But it's got to be the same thing. Something times itself. Something squared is 4x squared. The answer here is 2x. 2x times 2x is 4x squared. And then the other part are numbers that multiply to -9. And the one you're going to guess is probably the correct one, +3 and -3, but those are not the only numbers that multiply to -9. There's also -9 and +1 and -1 and +9. So how do I know it's 3 and -3? Well, these numbers need to add to 0. And how do I know that? Well, if you remember back from when we were doing, division and synthetic division and stuff like that, we had to recognize that there was a missing x term here, and we would often fill that hole with a 0x. So it's kind of like a trinomial where the numbers add to the middle. Same thing here. +3 and -3, they would add to a 0 term. And so there's kind of a missing piece in the middle. So that's how you know those ends need to add to 0. All right, one more type of factoring I'd like to show you, or one more group of factoring, and that's called grouping. Grouping is what it sounds like. We're going to group sections of the problem together. So whenever you have to factor a problem that has 4 terms, sure, you can look for GCF, and there may or may not be one. This one does not have a GCF. It's obviously not a trinomial because it's 4 terms, and it's not a difference of 2 squares because it's 4 terms. So the way to do grouping is, first of all, make sure it's in order, exponent descending order, like we always like, 3, 2, 1, none, and slice it in half, and group the left 2 and the right 2. And what we do now is really 3 rounds of GCF. I GCF the 2 terms on the left, so just these 2 terms, they have a greatest common factor of x squared. And I'm left with 2x minus 1. On the right, I have a greatest common factor of -4. And that leaves me with 2x minus 1 when I divide that out. So you GCF the left, GCF the right. Then I GCF the whole thing. What does the whole thing have in common? What does the left and the right have in common? They have in common a 2x minus 1. It's not a coincidence that they both end up with 2x minus 1. That's actually a requirement for this model to work. So if you end up with different things there, if this is 2x minus 1 and this is 2x plus 1, you made a mistake somewhere. Because that has to be the same so you can factor it away, and what is left over then, when I take 2x minus 1 from the left, is x squared, and when I take 2x minus 1 from the right, -4. So that's what's left over when I do grouping. So just make sure it's in order, cut it in half, GCF the left. Sometimes it's taking out an x, sometimes it's taking out an x squared, sometimes it's taking out more. GCF the right. Now, when you're GCFing the right, GCFing, I don't think that's really a word, but I'm going to use it. When you're GCFing the right, whatever sign this first number is, that's the sign of what you're going to be taking out. So if this was a +8, I would take out a positive something. So just note that. And again, I'm always looking for the common quotient, as we call it, right? Because that's what happens after I divide out a -4, I get a quotient of 2x minus 1. Once that's matching, I know I'm on the right track. I could factor that out from both sides and get what's there. Now, you may notice this can be factored, x squared minus 4. That is a difference of 2 squares. So that needs to be factored. This does not happen every time. Sometimes after you do the grouping part and the triple GCF, you're done. But you always should look at that. Even when we did here, we should look at these final answers. Is it a dots? Does this have if this was 2x minus 2, I'd have to factor out a GCF of 2. You know, if this was x squared minus 4, I would factor that as x plus 2, x minus 2. So a lot of times there's multiple rounds of factoring in the problem, so you always need to watch out for that. If this was x squared plus 4, cannot be factored because it wouldn't be a difference of 2 squares. But x squared minus 4 can. All right, the last one, and I'll try to keep this fairly short because I know I like to keep my videos under 10, and I'm already about 10 and a half. So this is going to be probably about a 12-minute video. This is called AC factoring. This is one of those more advanced trinomials. No GCF, 3 terms, but it's not that one where it has the invisible 1 in the front. This has a number in the front, and it's not a GCF. If it were a GCF, I could just take that out and then do basic trinomial. Now, this is what we call AC factoring. We actually call it AC factor by grouping. That's why it's in the grouping category. Because what we're going to do is we're going to take these 3 terms and we're going to stretch it to 4. And once it's 4 terms, and then I just do what I did here. Cut it in half and group. So how do I stretch it to 4 terms? That's really what's new here. Well, your front term, your A term, we call it, 3x squared, that stays the same. And the negative 5c term, that stays the same. It's the middle B term that gets split up into 2 new terms. How do we decide with those 2 new terms? Because they do need to be specific for this next part to work. That's why we call it AC, because this is our A term and this is our C term, and this is our B term. We want to know what is A times C, and I'm going to write that off to the side. A times C equals 3x squared times negative 5 is negative 15x squared. And notice that I put that on the side because that's really just a note for me to help fill this in. It actually doesn't get put down here. It helps me decide what goes here, but I keep it off to the side. And I need to know what multiplies to that, what multiplies to AC and adds to B. Just like we had the AM over here. Multiplies to C adds to B. Well, this is multiplies to AC adds to B. What multiplies to negative 15 adds to negative 14? The answer is negative 15x and a positive 1x. Negative 15x, positive 1x, add to negative 14x, multiply to negative 15x squared. Now that I'm at the 4 terms, I just do grouping like I did on the left. Cut it in half. GCF the left, I could take out 3x. I get x minus 3. GCF the right. Now there's no greatest common factor here, but I still want to take something out because whatever I take out as a GCF on the left and whatever I take out as GCF on the right, they kind of get grouped together as a binomial. So if I don't see anything to take out there, I'm going to at least take out a 1. And that's going to still leave me with x minus 5. Hold on. I made a small mistake, and I don't know if you caught it or not. You probably did. This isn't a 3. When I take 3 from negative 15, I get negative 5. And that's the beautiful thing about this method of grouping is these need to match. And they weren't matching, so I knew something was wrong. All right, well, I take that x minus 5 away from both of them, and I'm left with a 3x plus 1. So that's it, guys. Basic factoring and grouping, and we'll practice this later. See ya.